Do you see my whiteboard or no? Not yet.
Not yet.
Not yet. Okay, cool. Let me try. Let me try one more time. Now? Now?
Yes.
Okay. Well, this is, I don't erase the board. This is the last time. Okay, we start, it's just the beginning to explain the exponential function. Okay, those we discussed a little bit, not too in detail. One exponential that the base is 2. And remember, we have two scenario. We have when the base is greater than 1, gets increasing. Okay, I put in the blue color here. And we have when the base is less than or also in between 0 and 1, okay, decreasing. No? We're discussing now to complement this idea. Example 2 is, f of x equal the base is 1/2 raised to the x power. Okay, so the base now is less than 1. So I explained one day last time. Okay, in this scenario is decreasing. No, let me see here. It's decreasing. Okay, I can do a table again. Or no. No. Much better, in my opinion, is. Okay, I suppose you remember very well, or you know very well. Okay, 1/2 is 2 to the negative 1. So negative exponent means reciprocal. So if you replace this idea, this is 2 to the minus 1 raised to the x. And you apply one more time the exponent rule. Okay, every level of the exponent you multiplication, this is 2 to the minus x. Wow, this is equivalent to this. This is equivalent to this. To show you, this is equivalent to this. But in the second part, I see more clear because I know very well transformation. Yeah, I know. And when you are doing that transformation, you replace x for negative x. So as you compare the other example that we are doing in the last class, it was 2 to the x. Now we have extra negative here, no? A reflection. Reflection about y-axis. So say our graph. I show you in Desmos. Okay, our graph is similar. Well, let me try to do my best. Suppose quickly, roughly sketch. X, Y. And example 1 we are doing last time, the exponential was like that. Hey, noise. Who make a noise? Who make a noise? Miss Siggy, who make a noise? Okay, Anthony, you make a noise, no? Okay. The exponential that we discussed in last time was increasing, so growth population, growth, exponential growth, because the base is 2. Now, another okay, we are doing now, okay, 1/2 is reflection about the wax. I tried to do my best, but it was not good. Let me try to do again. It's something like that. You see now, and that's more clear, super elegant. This is 1/2 raised to the x. And the reason is clear. Because this is decay, is decreasing because the base is less than 1, and this is increasing because the base is, and it's exactly symmetric with respect to the y-axis, because actually we are doing reflection. Don't forget this important point, universal, 0,1. If you want 3 extra typical point was, for example, in the red 1, 1,2, 1,2, because it's obvious, no? Que the base is 2, when you raise to the 1 power, 2 to the 1 power is 2, no? And negative 1, this is a typical point, guys. Look here. I try to explain here. A negative 1 is 1/2. This point would be negative 1, half. Because the exponent negative is reciprocal, and actually negative 1 is the reciprocal 2, is 1/2. This is the 3 typical point, bang, bang, bang. And also, bueno, okay. And also, we have the famous horizontal line, que in this case, no problema, is on the x-axis, o sea, es a y equals 0. This is horizontal asymptote. Ahora, what happened with the blue? Well, the blue is similar. The blue, que es decay, que es decreasing, the famous point 0,1. This is universal, guy. Any exponential function passing through that point, regardless what base, si es 2, si es 3, si es 4, si es 1/3, 1/5, whatever. And the typical point are negative 1 is 2, negative 1 is 2. Why? I don't understand very well, because 1/2 raised to the negative 1 is reciprocal, and reciprocal 1/2 is 2 over 1, and 2 over 1 is just 2. And 1 is obvious que es 1/2. You see it magically happen que the value is, you know, reflecting. Reflection about the wax. Do you follow me, guys? You understand very well or no? Sure or no? Come on, guys. Are you there?
Yes, sir. Yes, sir.
Okay, yes, sir. Yes, sir. Okay. And so let me try to show you elegant graphic in Desmos. Switching to the screen. Desmos now. Do you see Desmos? Yes or no?
Yeah.
The first was this. Okay, I show you last lectures. You remember, right? I illustrate more points. I illustrate also the asymptote, the horizontal asymptote. Look at that. Let me flash it to see the effect. Now I want to show you both together. So the base is 1/2. Entonces, you know, nice, fantastic. This is reflection, perfect reflection about the wax. And the red one is exponential decay, and the blue one is exponential growth. And the reason is clear. When the base is greater than 1 is increasing. When the base is less than 1, not exactly less than 1, it's in between 0 and 1. It's a fraction, but positive, of course, is decreasing, que es exponential decay. Super clear? Okay, si it's clear, let's move on to 3 more examples to illustrate a little bit more new ideas. Look. Clear? Let me show you example 3. Oh, example 3 is y equal to raised to the x plus 1 minus 4. You see transformation. Entonces, according to the order of operation, the first transformation that you should do, or you should see, is x plus 1. And x plus 1, que es inside the parenthesis, is horizontal shift 1 unit to the left, because it's positive. Entonces, my exponential, you see now, you move a little bit, 1 unit to the left. And now, minus 4 is vertical shift 4 units down. Therefore, in this case, when you have vertical shift touch, vertical shift move the horizontal axis. Look at that. Let me show you. This is the graph in Desmos. but I want to discuss it in detail. This idea. I copy that. It's 2 raised to the x plus 1 minus 4. Entonces you see two red points, que es the y en el set, que es 0, minus 2, and the x in the set, que es 1,0. And you see also the vertical asymptote, que is at y equal -4. Because we have here extra -4 que produce the shift 4 unit down, because it's negative, no? But I want to discuss in detail these 2 point red color, red points, 0, -2 and 1,0. Let me come back again to the whiteboard to illustrate the algebra behind this. Okay, so the example that we're doing now is example 3, no? It's example 3. Do you see my whiteboard? Yes or no?
Sí.
I want to erase everything. So we're doing example 3. And example 3 is y equal 2 is the base, x plus 1 minus 4. So actually, see, you represent this in function notation. The thing we are doing is x plus 1 inside the parenthesis, the argument, minus 4. This is obvious, que es horizontal shift. In what direction? One and to the left, because it's positive. 1 unit to the left. And 4 is vertical shift, 4 unit down. Okay, but this is not important now. Suppose I want to find the point. The point, as always, y and z. Okay, you know very well the formula. The formula is evaluate in 0. So you replace x for 0. The y is equal to the 0 plus 1 minus 4. 0 plus 1 is 1. And 2 to the 1 power is 2. And 2 minus 4 is -2. And the famous point is the point 0, minus. Because the assumption that I suppose at the beginning was that x is 0. However, in order to find the x in a set, it's a little bit more complicated because the formula, you know, is f of x equals 0. Okay, but it's okay. Let me try to do my best. You put a y 0, so you put equation like that. This implies this equation 2 to the x plus 1 minus 4 equal to 0. Yeah, I try to do my best for solving this equation. It's 2 to the x plus 1 equal 4. I move forward to the right hand side. Entonces we face, at least the first time in our life, one exponential equation. Exponential equation. This equation, guys, que contain our unknown, que es x. Here, this x is the thing I try to solving. I solve for x. And the exponent part, that is the reason it's called exponential equation. So I want to explain it today how we're solving exponential equation because we are using frequently in this chapter. Okay, so now there are two kinds. I want to explain the easier case when it's possible express both sides of the equation using common base. It's obvious that yes, because 4 I know very well gets 2 to the second power. Let's see, we have, let me recopy here. Instead of 4, I copy 2 to the second power. In this moment, we have two exponential functions. And by the way, have the same base as 2. Therefore, automatically, the exponent is the same. X plus 1 equal to, so for x, 2 minus 1 is 1. And the famous point is the point 1, 0. Remember the assumption at the beginning was y 0. That is the reason that that's 0. And the x value que satisfies that condition is 1. And this is the y in a set, and this is x in a set. Everyone follow me? Everyone understand very well or no? I promise that we are doing 3,000 exponential equation today. Everyone follow me? Everyone understand very well? Yes or no?
Yes, Professor.
I bring 2 more examples, 4 and 5. Example 4 is similar, okay, but I want to discuss it more in detail. Y equal 1/2 raised to the x plus 4 minus 4 again. Okay. So I want to discuss several points. For example, first point is what kind of exponential is, remember, decay or growth? What do you think?
Decay.
Why? Please give me a reason.
Because of base number 1.
Exactly, because the base, que es 1/2, is less than 1. Cool. This is the idea. Now, entonces I know when you are finished to do that, okay, this exponential look like that, no like that, correct? No. Yes. Makes sense? However, we have another detail. We have transformation. What kind of transformation? Well, this x plus 4 indicate us, x plus 4 indicate us horizontal shift 4 unit to the left again. Okay, to the left. Now, -4 is vertical shift 4 unit down. Very, very similar to this. Okay, so now, conclusion, my horizontal asymptote is at y equal -4, correct? So when you are doing this, I suppose, I don't know, guys. I suppose that you are doing, this is my horizontal asymptote. Entonces now my exponential, I have no idea, look like that, because of the decay, no? However, it would be fantastic to find the y-intercept and x-intercept. So at that point, now we are using the same formula, no? To find the y-intercept, you declare fn0. fn0 is, in our problem, 1/2 raised to the 0 plus 4 minus 4. And we compute this, no equation, it's just arithmetic. This is 0 plus 4 is 4. And 1/2 raised to the 4th power is 1/16, no? Because the 1 to the 4th power, you know, 1 is a magic number. When you raise to the any power, it's always 1. And 2 to the 4th power is 2 times 2 times 2 times 2, 4 times is 16, minus 4. Then you combine like term here. Combine, no, you express the fraction, you subtraction, the least common denominator is always get 16, and we have 1 minus 64, no? 64 comes from the multiplication 16 times 4, no? That's subtraction is minus 63/16. And what is the conclusion, Professor? Well, the conclusion is the point R at the point 0, minus 63/16. This is the y-intercept point. That one is negative, makes sense. Minus 63/16. Okay, by the way, in decimal, let me put in my calculator. 63 divided by 16 is minus 3.93. It's approximately 4. Well, it's okay. Approximately 3.937. Okay, so 7.5. So far, guys, when I ask you on the test, approximate answer, standard in this chapter, we round off to 4 decimal place, okay? Pero negative. Sorry, I forgot the negative. I'm going to find the x-intercept. Well, this is more complicated. Well, no, actually, not too much. Is f of x equals 0. Who is f of x? F of x is 1/2 raised to the x plus 4 minus 4 equals 0. Okay, cool. Good. Let me try to do my best. Entonces, one more time, we have a complicated exponential equation. Because the thing I try to find equation is located in the exponent part. That is the reason there's exponential equation. Yeah, I need to do something in order to moving that place gets not countable and put like a linear equation, maybe, I don't know. So now I manipulate. How you manipulate? When you copy this, bring down, and move it 4 to the other side. Ya know que 4 is 2 to the second power. Ooh, what is the complication? Well, the complication is that when I need to manipulate, you have to express on both sides, using same base. And then you have the options, two options. You express it both sides using 1/2, or 2/2. I prefer 2. It's more logical, no? So I copy in one corner of the piece of paper. 2 is 2. 2 to the 1 power. And 1/2 is 2 to the minus 1. Makes sense, reciprocal. So you replace 2 to the minus 1 raised to the x plus 4 equal to the second power, get 4. Okay, almost. Now you apply the property when you have different level of the exponent. Suppose you have 2 to the third, to the 4, and you have here a. This is a to the 24, no? Que es the multiplication 6 times 4. This is the same rule. Entonces es you multiplication negative parenthesis x plus 4. You can write like that. Or if you prefer apply distributive property, you can do that. No problem. Let me continue here. 2 to the minus x minus 4 equal to the second power. Wow, fantastic. We have two exponential, same base, nice. Therefore, the exponent is unbelievable. It's a science fiction. How you eliminate the base when you guarantee, okay, you have equal sign in between two exponential functions and the base is the same, automatically the exponent is the same. And you convert magically this exponential equation to one linear equation. It's okay, like we solve it in elementary algebra equation. Okay, let me try to do my best. Minus x is equal to plus 4, que es 6, no? Minus x is equal to 6. And x is equal to minus 6. Okay, multiply or divide by -1 both sides. Therefore, our famous point is the point minus 6, 0. Cool? Yeah, at least you plot that. Okay, this point, okay, I predict, but I want to see it clear in decimals, is the point minus 6, 0. Everyone follow me, or you need one more example? I have another. Okay, so now you understand. In this example, the necessity. Well, let's move on to decimal to see the graph in detail. Switching to decimals. Okay. I have decimals. Do you see decimals? Example 4, no? I did example 4. Example 4 is, there you go. Bam. Look at that. This is exponential decay because the base is 1/2. We have two famous points. Get the point -6, 0, and the other point is weird. Is negative 3.938, que is the decimal approximation of the negative 63/16. And you see clear like water that our new horizontal axis is at the point y equal -4. Super. Any questions so far? Well, this is a moment. So you have no question, no problema. Because this is the moment to practice a lot of exponential equation. Okay. It's important, extremely important, guys. Extremely important. I promise that we using this in any application problem in finance and money, in physics, in biology problems. You apply exponential. And science in general. You need to know that. Switching to my Microsoft whiteboard. Do you see my whiteboard? Yes or no? Okay, because I want to discuss in details, exponential equation. Exponential equations. Okay, I bring a lot of examples. Example 1 of the exponential equation. So we focus it not in the graphic, no. We focus it in the solution. Suppose 2 raised to the 2 is 2? No, it's 3. It's 3. 3 minus x equal 8. Solve for x. Always the question is solve for x. Okay, I try to do my best. Remember what is the strategy? The strategy is clear. You manipulate both sides in order to express it using common base. This is the keyword, common base. So we practice a little bit. What do you believe is the common base? A or 2? Huh? I ask you, what do you believe is the common base? Okay, you can use it to express both sides. What is the common base? No idea? Well, let me try. 2 is 2. I understand very well this. But 8 is 2 to the third power, yes or no? 2 times 2 is 4 times 2 again, 3 times is 8. So you replace, not this equation anymore. It's 2 to the 3 minus x equal, instead of 8, you put 2 to the cubed power. Okay, now we have 2 exponential function, nice. So if this exponential and the base is the same, then you can write like that, or you can write using this arrow, it's the same. 3 minus x is exponent of the first is equal to 3, gets exponent for the second. So you put this and this equal each other. Entonces now es obvio que x is 0, boom, get the answer, final answer. Do you understand very well this or no? Come on, guys, let me know. Today is the day to solving 3000 exponential equation. Do you follow me or no? Answer me, please. I need feedback. Come on. Julio, Celine, Fabiana, Yailén, Armida, Angelina, Mia, Anaí, Brianna, Anthony, Patrick, Alberto, Nathan, Walter, and Daniel, no? Come on, guys, are you sleeping or no? What happened? This is easy, complicated.
Yes, I understand.
Okay, cool. This is the thing I want to know. Activate the microphone, you say, no problema. Oh, yes, we have problems. Explain me again, I don't understand anything, I am lost. Okay, I suppose it's easy. Okay, come back. Example 2. But I need help in example 2. Example 2 is easy, in my opinion. Is 5. The exponent is 2x plus 1. Guys, very important. Some students confusing and believe that this is equivalent to say 2x plus 1. No. This is 2x plus 1 is exponent. It's small and raised to this. Okay, no, this is a mistake. Now equal 25. Okay, my question is, what is the common base in your opinion? How? We manipulate both sides using one common base.
Is it 5?
Absolutely perfect. It's a 5. Because 5 is 5. And 25 is 5 squared. And you replace 5 raised to the 2x plus 1 equal not 25 anymore, is 5 squared. Therefore, 2 exponential function, same base, therefore, shortcut 2x plus 1 equal 2. And you magically, this is science fiction, this is magic. You convert exponential equation to linear equation. And the exponential disappear. Now rest is easy. 2x is equal to minus 1. 2x is equal 1. 2 minus 1 is 1. Divided by 2 both sides. X equal 1. Bam! This is my answer. The answer of this equation is 1/2. Equation. You get the idea? Do you understand the strategy?
Yes.
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 You have number 3. Example 3. I promise, okay, I want to confuse you. 27 raised to the 4x equal 9 x plus 2. Entonces I ask by myself, what is the common base? It's a challenge. Come on.
3, 9.
3, 9. Bueno, ¿es 3 o es 9? What do you think? Bueno, suppose que you don't know.
9.
You believe, you suppose 1. Okay. 9 is 9. But 27 is 3 times 9, no? Because I suppose que no good this. However, if you take 3 like a common base, 3 is a common base, you can express both sides using 3. Look at that. 9 is 3 to the second, and 27 is 3 to the third power, because 27 is 3 times 3 times 3. 3 times. So you rewrite this like that. 3 to the third power, no 27 anymore, parentheses, 4x equal 3 to the second power, que es 9, raised to the x plus 2. Everyone follow me in the transformation? Clear or confusing? Clear, right? Clear. Now apply one more time the exponent rule. You multiply the exponent, this is 3 to the 12x. Welcome from 12, 3 times 4. Equal 3 times 2 times parentheses x plus 2. I put the parentheses, it's important because these two multiply, we have binomial here, and multiply 2 times binomial. So you indicate like that, use a parentheses, no? One more time, we have 2 exponential function. The base is the same, it's 3. I create intentionally this idea. Now you write the linear equation associated with this. And you forgot that 3, no, not 3 anymore. Now you apply this 3 with the property. 12x is equal to 2x plus 4. So for x, 12x minus 2x equal 4. This is combined, this is 10x equal 4. Divided by 10 both sides. X is equal 4 over 10, or much better, 2/5. Reduce and lowest term. Divided by 2, you break it down to 4 like a 2 and 2, and 10 is 2 and 5. At least 1, 2 is cancelled, stay alive, 1, 2, and 1, 5. This is one possibility. Another possibility, you put in the calculator, 4 divided by 10 is 0.4. And 0.4 is equivalent 100% to 5. Cool? Okay. Remember, we're doing 3000 exponential equation. Equation 4. I want to complicate more, but you help me. And I suppose we can do that together. Suppose square root, what the hell, square root 3 raised to the x plus 4 exponential equation, because our unknown is located in the exponent part here. The unknown is located in the exponent part here. Now equal 3 to the x. What the hell? What is the common base? In your opinion? Don't be scared with the square root, because you know very well the relationship exists between, for example, radical 3 is 3 raised to the 1/2. Yes or no? Do you remember this or no? Well, I need to refresh your memory. No? Do you remember conversion, radical notation to fraction exponent or no? I need to explain or no? Yes or no? You remember, right? I don't hear. I hear something, but no, I don't understand exactly what the idea. Yes or no? Who say something?
Yes, we remember.
Okay, you remember, right. Guy, I need more participation, okay? Are you there or no? Or you are a student that open the computer and sleeping? Okay.
I'm here, Professor.
Cool. Okay. And you follow me? You understand? Miss?
Yes.
Okay. Okay, entonces, bueno, entonces answer my question. What in this example is the common base, in your opinion? Hmm?
3.
3. It's all because 3. Because in the first part is 3 raised to the 1/2 is equivalent radical 3 raised to the x plus 4 equal 3 raised to the x. Entonces multiplication, ¿no? Entonces 3 to the 1/2 paréntesis x plus 4 is one way to express this idea, no? Equal 3 to the x. Again, we have two exponential, same base, therefore the exponent part is the same. And you solve in this elementary equation. Of course, there are many ways to solving this. One fantastic way, in my opinion, is clear the fraction, because I don't like the fraction. You multiply by 2, the entire equation by 2, and when you multiply 2 times 1/2 is obvious 1, stay x plus 4 alive, no necessary parenthesis because there's 1 here, equal to x. Do you follow me? To avoid a fraction, you multiply the entire equation by 2. 2 by 2 times 1/2 is 1. And 1, you know, is invisible. And 2 times x is 2x. In this case, stay because we have no fraction. So now 4 is equal to x minus x. I move this x to the right hand side. We combine like term, 2x minus x is 6. The answer is 4. Excellent. I try to explain exponential equation, but I try to explain the most easy examples. I promise I want to complicate a lot of this. Not too much, but it's complicated. Example 5. I need help in example 5. 2 raised to the 1 minus 2x is equal 8 raised to the x plus 1. My question always is, what is the common base? Remember, what is the idea? The idea is express both sides using one common base. It's possible or no? Because sometimes no, it's possible. It's impossible. We need to apply another strategy, completely different. But so far, the example that I present to you now, always is possible. Convert everything to the one common base. What do you think about the common base? S2, S8, S4, S20, 20, S1000. What is the common base?
2.
2. Because 2 is 2, and 8 is 2 to the third power. This is 2 to the 1 power, no? This is 2 raised to the 1 minus 2x is equal to the third power. You replace 8 by 2 to the third power, x plus 1. One more time, we apply the exponent rule in which you have different level of the exponent. You are doing the multiplication. Entonces, in this moment, magically, two exponential, same base, therefore, the exponent part is the same, and you eliminate the base. And the rest is baby algebra. 1 minus 2x is equal to 3x plus 3. There are many ways to solve that. However, in my opinion, it's best you stay 1, bring down, subtracting 3, I'm moving 3 to the left, 3x stay here, plus 2x. Entonces, minus 2 equal 5x. Divided by 5, both sides. X is equal minus 2/5. That's the answer. Let me ask something. You copy and simultaneous with me, or you watching the video after, or you don't copy anything?
I copy it all.
You copy it all. Simultaneously with me, no?
Yes.
Okay, like a lecture, like a regular class in person. Okay, number 6, bring me new situation. Okay, we'll see if you can get or no. 2 over 3 raised to the x power is equal 9 over 4. Wow, confusing because it's a fraction, no? Oh. But my question is, remember the question is always common base, no? Common base. But there are connection between 2 and 4 and 9 and 3 or no? I suppose yes, right? For example, in the right hand side, instead of 9, I put 3 squared. It's equivalent, no? And instead of 4, I put 2 squared. Do you follow me? Now, this is square. If you want, you put here. Because what's my goal? My goal is try to stay one common base, no? But so far, I have 2/3 raised to the x equal 3 over 2 raised to the second power. So we have the same base or no? Yes or no? It's the same base? No, of course no. It's no. Entonces, what should I do? Well, you see que es recíproca. You see que es recíproca or no? Flip it, reciprocal, right? So the ideal is que you get the same base. Nice, I am happy. Pero I am not totally happy because I can see que one base is 2/3, another base is 3/2. It's totally flip it, right? Reciprocal. Entonces, no, let's do it. Entonces, either way, if you prefer, you copy this exactly the same. And you flip it that, but you put negative 2 exponent. Make sense or no? Remember, important in this chapter. Negative exponent, reciprocal. Negative exponent, reciprocal. Keep in mind this to understand very well that part. So we are ready now? Yes. What is the common base? The common base is 2/3. Entonces now, 2 exponential. Same base, es obvio que x is minus 2. Wow, final answer. Cool? Cool or no? I have 1, 2, 3 more. In the middle, we have one definition. Okay. Example 7. Oh, let me see. Example 7. Is, wow, cubic root of 5 raised to the minus x equal 1/5 raised to the x plus 2. Wow, I combine every complication in one problem. I combine radical, I combine negative exponent, I combine reciprocal 1/5 and 5. But I need to do my best to put each other equal, same base. Entonces, my challenge is discover what is the common base. In your opinion, what is the common base? No idea? Total loss?
Five.
5. Es obvio que 5. Es obvio que 5. The common base is 5 because cubic root of 5 is 5 raised to the 1/3. Okay, I need to do the conversion between radical notation to fractions point. And 1/5 is reciprocal 5 to the minus 1. Makes sense? Now replace. No square cubic root anymore. It's 5 to the 1/3 raised to the minus x. Be careful with the signs. Equal 5 to the minus 1, is 1/5 x plus 2. One more time, we are doing the multiplication, different level of the exponent. So we have 5 negative x over 3, because you know, multiplication of fraction, multiply numerator, denominator, I suppose this is 1. Equal, and you multiply 5 to the minus x plus 2, because the binomial is enclosed in the parentheses. Now, however, we have again the situation of the two exponential and the same base. Therefore, the exponent is the same. Magically, I delete the exponent. Minus x plus 2. Well, it's obvious that there are too many negative in this equation. You multiply the entire equation by negative 1 or divide by negative 1, and you convert like that. And now, if you want eliminate, get rid of the fraction, you multiply the entire equation by 3, no? You multiply by 3, it's just x is equal this and this is 3x plus 6. Okay, now ready. X minus 3x equals 6 positive, subtraction is minus 2x equals 6 divided by negative 2 both sides. Let's continue here. X is equal minus 3. And it's my answer. It's important that you see in this exponential equation, the answer maybe is positive, negative, or 0. The reason is clear because the domain of the exponential function is all real number. In other function, no. But in this function, yes, a nice function. Accept any solution, positive, negative. Okay, let me try to do two last equation involving the mathematical constant E, so number 9 and number 10 is two exponential, but involve one mathematical constant I want to explain now, que es e to the 3 minus x equal e to the cubic power raised to the minus x. This is my first, number 9. And my 10 is e to the x minus 1, sorry, equal parenthesis 1 over e to the 4th power x plus 1. So I want to recall, maybe you see in your high school, maybe the mathematical constant e. This constant is approximately 2.718 something, blah, blah, blah. It's irrational number, irrational. And irrational means that we have infinity decimal non-repeated places. Or another possibility to express the irrationality idea is that never you can express like a fraction. So we come from the e. I bring the not the PowerPoints, you know, the Excel spreadsheet explain very well this. But don't worry too much. It's just introduction, one definition. Who is E in mathematics? Who is E in mathematics? Let me try. E in mathematics is. Okay, I want to share another window. Get definition of the E. E definition. Do you see? Do you see the spreadsheet Excel? Do you see? Yes or no? Yeah. Okay. So this is the definition of the E. When you see that, you don't understand anything. Wow, what the hell? This is calculus. Maybe yes. But don't worry too much. This is, the expression is 1 plus 1 over m raised to the n power. It's exponential. But the thing is of the limit LIM, don't worry too much for this, is when the m increasing forever. So to simulate this formula, get the definition of the E, I create this spreadsheet Excel. So I put here 1, 2, 3, 4, 5, 6, 7, 8. I don't know exactly how you increasing this, and you evaluate this 1, 2, 3 is M, is the column is M number, and the Euler number is this E, and you plug in the equation. I simulate equal sign 1 plus reciprocal raised to the same power. Entonces I increase, wow, how many numbers? Thousands, infinity. You see that somehow the number I can continue if you want. And the answer don't change too much, but I create the graph to see more clear. Look, in the graph, you see how that number can plot in the other page converged to the one asymptotically to the one value. And this value is E. Okay, this is the approximation funny I can find in internet of the E, 2.7182. And entonces, what is important is? The important is that today we start doing logarithmic functions. And logarithmic functions include E, this mathematical concept. Okay, it's just general knowledge. You don't need to understand too much of this. The student can need to take calculus. The teacher of the calculus explain more clear this constant. Okay, so they are exponential that include E. Remember the exponential, there are no limitation for the base. The base is positive number, not 0, not 1, pero positive. And E is positive. Okay, it's one possibility. Okay, entonces you accept me que E is a constant. It's possible perfectly apply like a base of the potential exponential. Okay, no problem. Now I try to, let me erase that part, and we focus on the solution of this number 9 problem. No? Oh, it's easy. It's obvious that the common base is E. So now in the left hand side you have E to the 3 minus x. And the right hand side is a little bit more complicated. You multiply, it's E to the minus 3x. Apply the rule. Now again you have two exponential the same base, therefore 3 minus x is equal minus 3x. And we have linear equation. Let me try to solve this linear equation. I want to copy again.
Still showing the spreadsheet.
Sorry. I forgot to share. Thank you, mister. Sometimes I forgot. Okay. Now you see what about? You see whiteboard now?
Yes.
Now, let me start at the beginning. Okay, so now it's easy. You copy this exactly the same. Remember the same strategy. You multiply this exponent. Now at this moment we have two exponential at the same base, therefore the exponent is the same. You have a linear equation and you solve this linear equation. For example, one idea que I like is this x stay here, bring down. I move 3 minus 3 to the left like a positive, and you move this 3 to the right like a negative. And we combine, it's 2x equal minus 3 divided by 2. X is equal minus 3/2. Boom, is the answer. Yes, I'm checking in my paper. Likewise, number 10 is easier, is you copy e to the x minus 1. Oh, reciprocal. And reciprocal in my mind is associated with the negative exponent. This is e to the minus 4. It's equivalent, x plus 1. Now multiplication. Multiplication who? Negative 4 times x plus 1 is a binomial. And minus 4 times x plus 1. Okay, one more time we have two exponential. The base is the same, gets e. Now the exponent is x minus 1 equal minus 4 x plus 1. Okay, in this case you apply this derivative as minus 4x minus 4, and you try to do your best. Solve for x. But as always, it's a linear equation. Not always, but frequently, 99% of the time. Entonces, x stay here, plus 4x, I move to the left, positive, negative 4 stay, plus 1, I move to the right. It's a 5x equal negative 3. Divided by 5 both sides, x is equal minus 3/5. Final answer, 3/5. Let me check it in my paper. Yes, it's the answer. Cool. So far it's clear, but suddenly happy, I want to complicate your life. Why? Because there are another exponential equation that we cannot solve in that way. Example, elementary trivial example that you are stuck and you cannot solve it. This is 2 to the x equal 3. Suppose I put in the test, something like that. It's impossible. It's impossible. Not solving. Solving is possible. I want to explain how. Now, right now. But it's impossible solving using this approach yet that we were doing before. Because never you can express 3 like a power of 2. Never. Entonces now, to solving that, we need another more sophisticated tools. Que es el tool que I want to explain now, que es el logarithmic function. Logarithmic function. So logarithmic function help me a lot of to solving a special exponential equation that we need to solve in the real life. Okay, so what is the idea behind? I anticipate you que el logarithmic function, guys, is the inverse of exponential. This is the definition. So I suppose you remember at the beginning, last lecture, that we studied in detail inverse function. So now we study now two new functions. The exponential, that we start in the last moment, in the last lecture, and right now we study the logarithmic that I anticipate que is the inverse of the exponential. So what comes from logarithmic? I need to find the inverse of the exponential. Let me explain it. I want to copy the exponential one more time. A to the x. Remember, who is A? A is the base. Okay, and x is exponent, and y is the hypothetical result of the exponential. Okay, but I want to find the inverse. Entonces, it's easy. Remember the key idea is you interchange x and y. Always happen. I copy x equal a to the y power. Boom, and that's it. And this is the inverse. But the inverse, of course, as always, an implicit. Remember, implicit means that the y is not isolated. This is totally useless. I need to solve for y. So I need to do something in order to put y alone. And the terminology, symbolic way to solving this is using the name of the function is log, logarithmic function. We're using the first three letters, log. And to say now you need to understand the terminology notation. You put a small number here that represent the base. You put a parenthesis because it looks like a function notation, no? F of x. But the name of the function is f. Here in this case, the name of the function is no f. It's log base a. Bang! And this is the inverse. And this is the definition of the logarithm. But I suppose that you don't understand very well. No. Therefore, I need more clear interpretation. What is the interpretation? Let me try to interpret this. So now to interpret, I propose you one idea. I propose you, for example, express it. Some statement in both ways, in exponential and logarithm. This is exponential statement. And it's a logarithm statement. And they are perfect equivalence in between these. So any statement that you want, you can express it like exponential or logarithm. They are connection. That's the same. It's equivalent. 100%. Suppose we start easy. 2 to the fifth power is 32. If you want verification in your calculator, you see that this is good. This is typical exponential because the base is 2, the exponent is 5, and 32 represents the result of this hypothetical exponential. Okay. Cool, no problem. How you translate in this word, que es logarithmic? And by the way, it's reciprocal in both directions. You put log because it's logarithmic statement. Then you ask by yourself, what is the base of this? Remember, in the notation, you write a small a here can represent the base. That guy. That guy represents the base. However, in our specific example, the base is 2, because I saw here que 2. Look at that. This is the base, it's 2. Now, I open the parenthesis, I am confused, I have no idea, but I know very well that the answer of the logarithm is 5, and the number here is 32. These statements are equivalent, but this is a crucial moment to interpretation. And the logarithm statement, the answer que offer the logarithm is this. It's the exponent. Look at that. So what is the interpretation? The interpretation is when you compute logarithm base 2 of 32, you try to ask by yourself, wow. What is the exponent necessary? Can you raise 2 in order to get 32? Okay, this is the idea. Okay? Do you understand this or no?
Yeah.
Okay. Who helped me with the conversion, this statement? 3 to the 4th power equal 81. How we convert to the logarithmic statement?
Log
You put the
base
word,
Base 3. 81 equals 4.
Excellent. Okay, because you put the magic word, the keyword log, logarithmic statement. The base is 3, you see clear like a water. Look at that. So this big tree is this small tree in this statement. And the answer outside is the exponent. And the number inside the parentheses represent, you know, the result of the hypothetical exponential. Okay, in conclusion, in general, we practice now. This is two motivation example, but I want to copy the formula, but I want to copy, let me see how many, 1, 2, 3, 4 more examples. Can you help me? In both direction, conversion. Look at that. The idea is you have base, you raise to the exponent, and you get the result. So we are in the exponential world. Okay. How you write in the logarithm world? Well, easy. You copy log, because it's the name of this function, and you put a base here, a small number. So that number you copy base, but copy in small. Open the parentheses. You know that the answer get offer. The logarithm always is exponent. And here we have the result. This is the formula in general. This is the formula in general. Let me try. I bring, I suppose 20 example of the conversion exponential to logarithm, or in both direction, guys. You need to, we will be able to do the conversion in that direction or in that direction. So maybe it's given in logarithm and you convert to exponential, or maybe it's given in exponential and you need to convert to logarithm. Okay. Today, basically, the lecture today is the intuition of the logarithm. Important. 3 important. Next time, next Monday, everyone bring mandatory calculator, scientific calculator, because we are working with these special functions, and it's impossible to do it by hand. Actually, logarithm is impossible computed by hand. No, we need calculator. What kind? Scientific. No super expensive. No, cheaper. Walmart 12 bucks. For example, TI X30. 12 bucks. Walmart. Or Office Depot. I don't know. I don't care. No advisor. No commercial. Okay, now suppose this. Suppose it's given this. I change the flavor a little bit. Logarithm base 4 of 64 equal, I don't know. This is example A. Example of the conversion. Example 1 to practice. I bring more. Entonces, wow, I'm confusing, professor. I don't understand very well. I want to show you after, no, but not today, how we computed this in the calculator. But today, no, today is the day by hand. Everything by hand. Interpretation is understand what means logarithmic function. Suppose you don't know. Okay, no problem. I understand very well. But you know how we convert this confusing logarithm statement to exponential statement is easier in my opinion. So I ask by myself, what is the base? Well, the base is 4. This small 4 represents the base. I copy big 4. What is the exponent? The exponent is the thing I am looking for. I don't know. It's x equals 64. Do you understand the conversion? Do you understand the conversion? Logarithm statement to exponential statement. Do you understand or no?
Yeah.
Cool. Now you try to do your best and the calculator or by hand. Either way, 64 is 4 to the third power. You multiply 4 times 4 times 4 3 times. Oh, it's 64. I got it. Therefore, one more time, you get 2 exponential, it's the same base, therefore the answer is 3. Everyone follow me? Everyone follow me?
Yes. Yes.
Okay, now logarithm base 10, 10 is easy to understand, of the 1000. No idea, totally lost. Okay, guys, we can use intuition also. You can use intuition. I want to illustrate the intuition, but not now. Because in this moment, totally lost, no idea. However, I know the conversion between logarithmic statement to exponential statement. I know that the base is 10, the exponent I don't know, is equal 1000. Do you understand very well this part, guys? This is the most important. The rest is pretty easy. The conceptual part is this. How we convert logarithmic statement to exponential statement. And 1000 is obvious que es 10 to the third power. Yes or no? Because it's 10 times 10 is 100, and 100 times 10 is 1000. Therefore, it's obvious que x is equal to 3. Let me continue for the base 10. It's easy, intuitive to understand. Base 10 of 100. What do you think about that? What is the answer of this? Without do anything, using intuition.
X equals.
Exactly. Very well. How do you know? Give me a reason. Why? Because
10 times 10 is 100.
It's 10 squared. Oh, 1 intuition. Look at that. How many zero we have here? 1, 2, 3, no? And the answer is 3. And how many zero we have here? 1, 2, and the answer is 2. O sea, it's super easy. Si the base is 10, the base is no 10, entonces we can apply this intuitive idea. Suppose example 4. We continue with the base 10 I like so much to explain the intuition of 10. Uy, what the hell? Logarithm base 10 of 10. Try to follow in the same pattern. No idea. Don't worry. You relax. You put x. When you don't know something, you put x. And you convert to exponential. The base is 10. Be careful with the 10 because we have 2 10. But the smaller one in the bottom is 10. The exponent, no idea, equal 10. It's obvious que 1. Because x is 1. Yes or no? Entonces we conclude this. It's important, this idea. Look, when you have logarithmic of the any base, and by coincidence, the number inside the argument is the same, the answer is 1. There are 3,000 examples. Logarithm base 2 of 2 is 1. Logarithm base 3 of 3 is 1. Logarithm base 1/2 of 1/2 is 1. And this is obvious because what is the exponent que es necesario raise the base to obtain the same number? Es 1. Make sense?
Yes.
Yeah, it's easy, but it's important the interpretation. I want to complicate a little bit your life. Look, we continue with the easy base 10. 0.1 decimal. Uy, what the hell? I am lost. I suppose that the intuition fell a little bit. No, I don't understand very well. Okay, no problem. Therefore, I copy this logarithm statement to understand much better to exponential. The base obvious que es 10. This 10 is this 10. The exponent, no idea. And 0.1. And 0.1, you can express like a fraction, 1 over 10. No? And 1 over 10, I can express it using negative exponent, reciprocal. Yes or no? In this moment, we have 2 exponential with the same base. Therefore, x is negative 1. Oh, important. Look. some important property that we discover about logarithmic. So we are doing in the new world of the logarithm. So we discover some property. Suppose that the base is bigger than 1. But suppose that the result inside, or the argument, whatever argument, is less than 1. And so the answer of the logarithm is negative. I'm making sense because there are one connection with the reciprocal. Flip it, right? So this situation happens completely equivalent in any problem we discussing now. So when the base is, suppose another scenario in which the base is less than 1 and the number is greater than 1, to say again we have reciprocal. But okay, let me try another example. Example 6, the last one of the logarithm of 10, 0.01. Wow, what the hell? Using intuition, intuition. What do you think? Is positive answer or negative answer? Negative something. I repeat the idea. When the number and the base is different, maybe nature. This is the base is greater than 1. And this guy gets 0.01 is less than 1. I want to call different natures because one is greater than 1, another less than 1. So the answer you think obviously is negative. Negative something, no? Negative something. Do you see what is negative or no? Negative 1, no, because negative 1 we computed before was this. I don't know. I'm lost. I call x. I try to convert shown to exponential. This is 1 over 100, no? Okay, it's 1 over 10 squared. 10 times 10. And it's 10 to the minus 2, reciprocal. Therefore, it's obvious that x is negative. Do you follow me? Do you understand very well or not? Sure?
Yes.
The thing I try to transmit today is the intuitive idea for the logarithm. Because after that class, we compute everything using calculator. So in the calculator, you lost the interpretation of the thinking we are doing. Okay, two more examples, and you help me to understand this. And you at least tell me if it's negative or positive. Logarithm base 5 of the 1 over 125. Bang. Okay. First of all, you analyze. Is positive answer or is negative answer? And why?
Because
Positive or
less than 1.
Is less than 1 the argument, no?
It's negative.
It's negative. Why? Explanation.
It's less than 1.
Who is less than 1? This is less than 1. Right?
The argument.
And wait, what happened? It's incomplete, the answer. For example A. Logarithm base 1/2 of 4. What do you think? Is negative or positive?
Positive, because the argument is greater than 1.
No. This is not the idea. I want to explain one more time. Okay, let me create 2 more examples. Example 9 and example 10. I change a little bit. It's similar. Suppose logarithm 1 over 125 is the base now of the 1 of the 5. And this is logarithm of the 4 of the 1/2. Okay, you see that we have a contradiction. So what is the contradiction? the argument is less than 1, it's exactly you say, cool, I understand. But the base is greater than 1. So you have contradiction. And when you have contradiction, you expect negative solution. Do you see that? Because remember, the thing we are finding is exponent. And this, when you have negative exponent, you have flip it. Then you flip it something, right? Suppose one, okay, intuition. This is intuition. Little by little, you understand. Let's find the exact value. X, no idea. You express it, this statement to exponential. The base is 5. The exponent, I don't know, equal 125. And 125, you put in the calculator, 5 times 5 times 5 is 5 to the third power. And you see reciprocal que es 5 to the minus 3. Es obvio then que x is equal minus 3. Cool? But I intuit this negative answer because this argument is less than 1 and this base is greater than 1. We have contradiction, we have negative exponent. No contradiction, positive exponent. Suppose que I change a little bit this. I put 1/5. What do you think? No idea, totally lost. You believe que es negative exponent or positive exponent? No idea, guys.
Positive.
Absolutely positive. Because this guy is less than 1 and this guy is less than 1. No contradiction. You don't need to flip anything. Therefore, the answer is positive. Let me try to do my best to find the value. To find the value, as always, we convert this statement to exponential, and the base is 1/125 raised to the x power equal 1/5. Right? Okay, we're focusing on this exponential equation, but I know very well that 125 is 5 cubic. I know very well. Bueno, si es recíproca es negative. It's actually 5 to the minus 3 raised to the x, no? Is equal 5 to the minus 1 raised to the nothing. Because it's just not necessary this parenthesis. Now, one more time, you apply the multiplication. Entonces, 5 to the minus 3x is equal 5 to the minus 1. We have two exponentials, same base. Negative 3x is equal minus 1 divided by negative 3 both sides. X is equal positive 1/3. Do you understand very well the idea now? Contradiction and no contradiction. No contradiction positive, contradiction is negative.
Yes.
Entonces now, in the real life, you don't need to know. You put in the calculator, and the calculator, give me a sign. You say, okay, it's because there are contradiction between the argument and the base. Entonces now the exponent I need is negative because I need to flip it. That's it, end the story. Now, this is a crucial moment. So you understand very well the intuition of the logarithm. This is the crucial moment to see the property of this new function, que es logarithmic function, que by the way, is the inverse function for the exponential. So I propose you switching to decimals, and decimal you see the graphic of the logarithm and intuit the property. What is the property, guys? The classical property any function. Domain, range, asymptote, y in a set, x in a set, blah, 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 blah. Let's do it. You let me know si you see or not decimals. Boom, boom, boom. Do you see? Okay. Yes or no?
Yes.
Okay.
Yes.
Okay. Look at that. Okay, I want to show you one more time the exponential. And the base greater than 1, que is growth, exponential growth, or increasing, whatever you want to call it. However, I want to find the inverse function of this, and the inverse function is logarithm over base 2, and look at the graph there. Bam! This is super clear because you remember very well que the inverse function. Let me change the color. Let me put in the inverse, in the logarithm, I'll put red color. Red color is logarithm, blue color is exponential. I show you now the relationship between exponential with the same base, 2 in this case. And the only thing you should do is interchange x and y. Suppose that point, que es 1,2, now would be 2,1. 2,4, 4,2, and so on. Important. Then our original exponential contain horizontal asymptote at y equals 0. Well, without transformation. But the logarithm contain vertical asymptote at x equals 0. So in this case, coincident with the y-axis. I try to flash in order you see more clear. Cool? Super cool? Do you understand very well? So now is a crucial moment that you're connecting any concept. You connecting the inverse functions, but specifically exponential and logarithmic. It is one specific case of the two functions that are inverse each other. Okay. Clear, guy, or no? No? Confusing? I have another idea. Clear? So far it's clear or no? Answer me, please.
Yes.
Yeah. Okay, cool. Now. Let me show you the exponential decay that we studied before, and what is the inverse of this. In this case, the base is 1/2. That's the reason it's decay, but the logarithm also says like that. Whoa, look at that. It's logarithm 1/2. 1/2, base 1/2. You see, it's expecting that if the exponential is decreasing, the logarithm is also decreasing, no? And to say, maybe you see more clear now. Let me try to see more clear now. For example, logarithm of the number less than 1 is positive. In this scenario in which the base is less than 1. And logarithm of the number greater than 1, like a 2, like a 3, like a 4, is negative value. Okay. Together, you see clear the reflection. So in this case, the red one is the exponential, and the purple color is the logarithmic. Very well. Well. Entonces now is a crucial moment. Ay. Do you have calculator or no? In this moment, you have no calculator.
Yeah.
You have calculator? Okay, let me try to. I have one calculator. Let me try to find one calculator online. I have one calculator online. But let me see. Okay, one calculator online. There you go. I suppose que es this. Entonces I open, and you let me know si you see or not my calculator. I have one calculator here. I have three calculators. But to show you like emulation, no? Emulator, that working quickly, perfectly. I have one calculator here. Okay, open, and I want to share with you. Let me know if you see or no. You see? Oh, let me see. Wow. Do you see or no?
Yes. Yes.
Okay,
Yeah,
cool.
yeah.
Do you see only calculator, no? No whiteboard, no? Only calculator. Just calculator, no?
Yeah.
Okay,
Yeah.
no problem. It's okay. Okay, let me try to find the functions. And this calculator is different, no? You need to understand your own calculator, guys. So now I recommend next time, everyone bring the calculator. We practice. But today, in the time we have, only you watching this, I want to explain two things important and stop for today. Next time, everyone mandatory bring calculator. So you click in the function. For example, in this calculator is different, and the calculator I have in my hand, actually, this is virtual. And the function you press, and you have two kinds of logarithm. This log, and you have another case lm. I want to explain it. Who is that? For example, logarithm of let me try to main 10. Oh, not 10, 1000 is enter S3. Okay, when you see log and no specification the base, default, you suppose que es 10. And this is called common logarithm. Don't worry, I want to write in detail this in the whiteboard now. However, when you present the function lm, it's another kind of logarithm. And for example, you put main, the mathematical constant, or whatever, fine. This is the irrational number. This is natural logarithm. So now we have, okay, do you see that, right? Let me come back to the whiteboard. And the whiteboard I want to explain clear. And this is the last part for today. Look. You see whiteboard? Yes or no? No? Yes?
Yes.
Cool. So we have the standard logarithmic. Functions. And what is that? This is the logarithm that we have in our calculator. And this is the logarithm that we are working all the time. So the first one is called a common log. In the calculator, you press the key log. The majority of calculators have one key, que es log. And default, you suppose that the base is 10. So when you compute log in the calculator and you put here 1000, que es 3, it's because I suppose invisible 10 here. So now, don't ask me when you see in the test or something log and no specification the base, default you suppose es 10. Ese como lo es. However, o sea, log alone es equivalent log base 10. We have another que es natural logarithm. What is the reason we have two logarithms? Because this is used frequently in science, physics, chemistry, this guy. However, this is used in calculus. The reason is no trivial, pero the teacher de calculus explained what is the reason. Entonces, en calculus, you forgot this. In chemistry, you forgot the natural. And the natural, you press the key LM. and the base is the famous E, mathematical constant that we learned a few minutes ago. Entonces now, equivalent log base E is equivalent LM. Ese notation. Okay? LA, natural. LOG, common. Okay? Okay, that's it. Bueno, we have, let me see how many minutes, 5 minutes. And the 5 minutes, I want to solving the equation that we have pending. Do you remember this equation that we have pending? 2 to the x equal 3? Well, okay, you can. In this case, it's impossible. Solving by the traditional way. However, if you apply logarithm on both sides. But what kind of logarithm, coño? We're using common, standard. Maybe common or maybe natural, whatever. You apply logarithm on both sides. So you apply log of 2 to the x equal log of 3. Entonces now, no specification of the base because I suppose that the base is 10. So we are working with the common standard, no? Common standard. No. Well, entonces I want to explain, but in the next class, que we have one property, que es magic. That property is que this exponent x fly outside. Entonces x log of 2. I want to explain why, but in next class. log 3. Entonces magically you convert this equation, this exponential equation, in one linear equation, but in different way. Because, you know, look like we are, but it's linear. log2 is just a number. log3 is just a number. We are number, but it's a number. Exactly like you do have 2x equal 3. I know that it's not the same, of course. But in this linear equation, divide by 2, and in the story, I divide by log of 2, both sides. And the answer is, this is cancelled, it's obvious, no? It's x alone, it's logarithm of 3, divided by logarithm of 2. And I see, Professor, well, yes, this is the exact answer. It's totally useless because in the real life, we need a approximate answer, no? So approximate PPP entonces now this is a crucial moment que we need the calculator, no? Let's do it. Entonces this is the last thing we are doing today. Too much. But no, I want to do the calculator. Hello. Okay, calculator, do you see? No, you don't see, no? Let me see. Wait. Share calculator. Do you see calculator or not yet? Do you see? Do you see? Off. Not yet. Now?
No.
Yes or no?
Yes.
Or no? Yes. Okay. So basically, I press the function. I try to find log of 3, no? Outside the parenthesis, divide by division. log of 2. Okay, to say next time we practice, to say the answer, what the answer, look at that. The answer is, I want to copy it, 1.584962501. Do you see that? It's obvious, because it's irrational number. An irrational number have infinity non-repeated decimal digit. Therefore, of course, you truncate or you run off normally to the four decimal place. Entonces es you truncate You truncate. Let me copy in the whiteboard the approximate answer. The approximate answer is whiteboard. I forgot. Switching to whiteboard. Okay, there you go. Whiteboard. Do you see my whiteboard? Guys, the last moment. I copied the answer. 1.58 49 62501. However, in the question, in the test, specification, I need 1, 2, 3, 4 decimal places. So you take a look. This digit. See, this digit is 5 or greater than 5. You increasing this. But actually, my answer is 1.5850. Yes or no? And this is the thing we are doing next time.
Yes.
Okay, guys. Thank you so much for your attention. Remember, today, submit the test online. Okay, and I will check it tomorrow in the morning.
Professor, the only thing is homework 6 is closed. It says it will close on Monday.
Really?
Yeah.
No,
Everything else was open.
It's one of those I can only the 6 and the 4 and 5 is okay.
Yeah, those were open.
Because I activate. Don't worry. Maybe I make a mistake. I activate right now. Okay, guys. Bye bye. Bye bye.